This talk is really more of a tease really than a talk. My time's a bit limited, so I'm going to try and avoid any deep technical discussion. You can come and see me later if you want to talk about anything. But hopefully I'm going to make up for it by showing you something you may not have seen Scala do before. I'm going to talk about Indigo, which is... Sorry, I'll stop turning around for the lady. I'm going to talk about Indigo, which is a game engine I've been working on for a few years now. I'm hoping to make it available soon in some sort of alpha, so you can give it a try and tell me all the problems with it, because there are many, I'm sure. Have I missed anything? I have. Right. Yeah, sorry. So my motivation for building it was that I wanted games programming to be fun again. And fun for programmers particularly, and specifically for me, it's a very sort of subjective thing. There's a few things that spoil the fun for me with the big commercial engines, like Unity. There's not very many code-only engines, because I'm a programmer. Right. You okay? Oh, thank you. Very kind, yes. I'm going to kick that though. Okay. I don't really like those because the big engines, because they tend to come with big GUIs and asset pipelines, which are kind of designed for teams. Haxi is a good notable exception to that. There's a distinct lack of functional programming engines. The only one I know of is Yampa. If anybody's tried it, it's a Haskell thing. It's really quite intimidating. And the other thing is testing, right? I used to be a Flash programmer for my sins, and testing is something that I take for granted in my day-to-day work, but I've always found it really difficult on the front end. And we're going to talk about why that is a little bit. To kind of get you thinking about the problem space, and to challenge the conventional wisdom that testing games is hard and more difficult than other things, I'd like to give you an example about where some of this idea is coming from. Okay. I must warn you, there's a slight pirate theme to this talk. Apologies. It just happened by accident, and then I carried on because I was enjoying myself. So picture the scene. It's the early 1700s. It's the golden age of piracy. There's a Spanish treasure galleon en route to Manila. Its hull bursting with gold, which is plundered from South America somewhere. And when it's attacked by a lone pirate ship. Okay? After exchanging blows, each ship is badly damaged. One more hit is all it's going to take to sink either vessel. Okay? Just one. And in the same moment, both captains of the ships shout, "Fire!" Which ship sinks? The other thing you have to know is, of course, it's a video game, because it's not real life. It's single-threaded. The cannonballs have no fixed flight time at all. And alignment guarantees maximum damage, right? So you can't miss, right? As long as you're lined up, you're going to hit, okay? Which ship sinks? Well, here's a naive implementation. It's terrible. So we loop over the ships in order, right? There's an array of ships. There's pirates and there's a treasure ship. If the current ship isn't destroyed, then we attempt to find a target in our line of sight, and if we find one, we destroy it, right? Stepping through it, the ship in position 0 is evaluated and destroys the ship in position 1 of the array. We move to position 1, but it's already dead, so we do nothing, right? Which is not fair, because they both fired at the same time, quite clearly, right? The bit to notice here is target destroy, near the bottom there. That's kind of the important bit, because that is a side effect that is reaching out into the world, mid-frame, and mutating the state of the world, which is kind of knackering everything for us. And this changes how the rest of the frame is processed, how it's going to proceed, and it gives you an unexpected outcome. Perhaps the removal of the second ship early now means that some other ship that would have hit the second ship can now hit the first ship. Who knows? To be clear, of course, these are solved problems. Game programmers don't know how to do this. This is a terrible example. I'm just trying to give you a sense of what we're talking about. Okay. But things are about to get worse for our games programmer because the designers are not happy. They want more ships. They want at least 50 ships. They want squalls of high winds. They want random rogue waves, and they want the occasional sea monster. So what we've really done is we've taken a slightly hard to reason about problem, because we're not very good programmers and we wrote that terrible piece of code that I showed you. And we multiplied it by 50, and we've added a whole bunch of random to it. Okay? More pirates. There you go. At this point, if somebody asked me to test that, I think I'd just throw my hands up in the air and say, no, I'm not really sure how I'm going to start there. Maybe we'll just hire a bunch of kids and lock them in a room and make them play it until they break it. That's probably the best way to go here. How do you test something that seems completely non-deterministic and random? it's quite an overwhelming problem. And how much, even if you do manage to write some tests, how will you have any confidence that you've done enough at any given time? So, problem recap. Side effects, mutable world, modifying the world mid-frame. If you can't see where I'm going with this, you're probably in the wrong room. Surely functional programming has an answer, because that's what we do, isn't it? Side effects and no surprise. What if we could just somehow design a process that gets rid of this problem altogether? Right, that's the challenge. So this is the solution I came up with. It's a slight anticlimax because it's quite a boring looking function, but more on that in a moment. It took me a very long time to arrive here. I'd done some Elm and I'd done some other stuff, and eventually one day I got to this place. But I can explain in about 30 seconds because I have this piece of code. I can leap you all forward a bit. Everything comes down to this function. The things to notice are all of the inputs are immutable and predictable, right? So we've got game state. This is the result of the previous frame. We've got the game time. This is an idea from a branch of theory called SRP, where you sample time and you just say to the rest of the program, this is the time, right? And everything is assumed to happen instantaneously. So you get rid of race conditions. List of global events that occurred during the previous frame, input state, frozen snapshot of the inputs, what buttons were being pressed, where is the mouse, and this thing called a dice, which is my version of random, where I preceded it with something that I know it's going to be, so we can replay it. We can replay the frame exactly as it was before, right? Ignoring the game's state, all of the outputs then are monoidal, if you know what that means. The game state has to be passed on to the next frame, but the list of global events is clearly a list, not a wide. And we have this other thing called a scene update fragment, which is essentially a monoid that represents a partial scene, right? Just a bit of it, and you can squidge them together to make bigger scenes. Again, slightly underwhelming function, but it has a few massive implications. The first one is every frame in the game is completely deterministic. Because we have referential transparency, testing complex scenes suddenly feels possible, right? Because you can just replace an entire frame with an answer. And all games, in effect, are mechanically composable, right? What do I mean by that? Imagine for a second that you could compose Sonic the Hedgehog with Super Mario Brothers by doing monoid append. Don't know why you would do that, but you could. There you go, free idea. Right, and with that, I'm going to stop and try and do a demo. I told you it was going to be light. I'll try and walk you through how something's built. I heard that people enjoy things more when they see where they're going first, so I'm going to try and show you it working. But first, I have to fiddle with the monitor, so bear with me for a sec. Mirror, please. Okay, that. Hopefully we have some sound. Okay. This is the Cursed Pirate. I made this demo just for you lovely people for the weekend. It took me about 6 hours. All the assets cost $30 on itch.io if you're interested. You too can make one of these. Got my little game pad working. He's the Cursed Pirate because all he can do is walk left and right on his tiny patch of land. And when he gets bored and commits suicide, he comes back. Poor little guy. Okay, so that's what we're making. I don't know how I'm doing the time. Please clean the time. Who knows? Me? Okay, somebody tell me. Okay, enough of that. Right. Annoyingly, I'm in exactly the wrong place. Bear with me just a sec. This is not going to be live coding, this is going to be live uncommenting. It's going to be as exciting as it sounds. Okay, right, so let me just rebuild that. Blessed silence. Okay, we might want to turn the sound down soon, just so that people don't go absolutely crazy. All right, so I've just got some steps. I'm going to walk through them, and if I run out of time, somebody tell me. Okay. So step one here is to do nothing. Nice blank screen. When you build a game in Indigo, what you have to do is extend one of the traits. There's only a couple of them at the minute. The first one is a...
Sorry, could you zoom in?
Ooh, yes. I actually meant to ask that. Apologies. I had a whole list of things I was supposed to go through on that last... Okay. Right. How do I do that? Do I just do this? Oh, look, how's that? Better?
Presentation mode, no.
Ooh. Oh, it's a bit scary though.
That's all right, that's fine.
You sure?
Yeah.
Thank you. Thank you. Generous. Can you see the back? Yeah, you're all right. Good stuff. So, when you make a game in Indigo, you have to extend the traits. This is the most basic one. There is another one, at least one more, which does, I forget, I made this stuff so long ago. I've been working on it for years. Which does scene management and things like that for you, so you don't have to think about it. It uses lenses to move the state in and out of the scenes. And what you do is you set up some config. This was designed for pixel art, because I'm a pixel art advocate. I also use that as sort of creative constraints, because it means you don't have to think about boring things like rotating stuff. And you can put everything on a pixel, which is lovely. So this has got a magnification of 2, and it's running at 720p. There's a bunch of things you can use to set stuff up. I'll come back to some of that later. The main guts of it is this, though. If you remember back to the frame processor, there's a bunch of simple inputs to produce a bunch of outputs. And all that we're really doing is we're taking these functions, and these are all the same arguments, and we're composing them together to make that one ginormous function. All right? So we've got a setup function for things that you might want to do at the beginning, like parsing JSON and creating assets. An initial model state, if you've done Elm, some of this will look very familiar. Update is updating the model with the latest version. Initial view model is, we've got a different separation than Elm, though we've got a view model as well, for reasons that I'm going to talk about some other time. And then there's this presentation function. And all that we're doing in the minute is nothing. So we have a scene update fragment which is empty. Okay? Right. Something more interesting. Step 2. How about a background graphic? So all we can, well, let's just have a look at it. Come on. Ah, prettiness. Okay, bit boring though. So all we've got here is a graphic. You have to tell it, because Indigo's a bit stupid, you have to tell it how big the image is, what depth you want it to go at, and give it a reference to the asset that you loaded earlier on. I'm going to rattle through the first couple of steps quite quickly until we get to something that's actually interesting. So here's our background graphic again, but now we're doing a monoid add to scene audio. I should point out there's no cats here, right? I didn't put cats in it because I want you to use cats, right? That's the point. I don't need to be stuck by what version I've included in the library. So I've just done it all myself.
What is that part plus plus?
It's just an operator I've made. You can write combine as well if you want to. So this is the scene audio. So again, a scene update fragment represents part of a scene. So here we're including a single track loop, which just goes round and round and round and round and round annoyingly forever until you all go a bit mental. And you can change that at any time. As soon as you render a different piece of audio, it turns off the first one and puts on the second one. Okay. 4. Animations. Okay, so now. Oh, sorry. Show them the pictures, Dave. Show them the pictures. Right. Oh, so we've got our audio from step 2, which I didn't show you. Step 3, we have little shimmering water bits. Isn't that cute? Thank you whoever made those assets. So the way this works is the same idea. I've got some assets which I loaded earlier. Let me see if I can show you that. So we're loading things in from a program called ASC Sprites, Easy Sprite, I think it is actually, which is really great for pixel art. It only costs about $15. I think I bought it twice because I lost the first one. I couldn't be bothered to find it. I paid for it again. It's really good, and it exports JSON and sprite sheets of lovely animations, and you just load them in because I've built an importer for you. So we load in the assets, stick them on the screen, and press play, and we move them around a little bit so that they're in offset. Okay, right. Foreground. I'm kind of jumping along here because I want to get to the interesting stuff, and this isn't very interesting to me. This is running about 60 frames a second, by the way. It's Firefox. This is all completely vanilla Scala. The engine is 95% vanilla Scala. The idea is that you should be able to target JS native or JVM at the end without doing anything to your code base. And it's all rendering at the moment to WebGL 2. So here's all my foreground assets. It's easy. Right, on to the good stuff. Where is that step 7? I'll put that back, just in case. When I've been making this, I'm going to show you what I've got here before I explain what's actually going on. Sorry, I left a head there, didn't I? Didn't mean to. Right, so ignore all that stuff I just put on. Here we have big fluffy clouds, and it starts to look more like a sort of a sea scene, right? One of the things I discovered when I was making this is there's an awful lot of boring things in games that must be programmed, right? My favourite example I keep going back to is, you know the lovely rattle on a pinball machine when you put the score up and it goes, right? You would never save any information about how that works. All you really care about is the current score the guy is at, right? But you still have to program all this animation going on in the background. So wouldn't it be nice if you could just write a completely separate game and all it did was that, and then you just squidge them together? Well, that's what we've done. So, here is they're called subsystems. It's just a case class. It's telling a subsystem. It carries its own state, so I can save it really easily. You get an update function, where you've basically filtered out which events you're interested in that are coming through the main event loop. And then you have render, and once again it's producing yet another one of these monoidal scene update fragments that you can just squash together everything else. So this one is just moving a cloud across the screen very, very slowly, and that's all it does. Okay? Going a little bit further, this is another subsystem, if I can get it right. But this one's a bit cleverer, and also less efficient, but I'm dealing with that later. So what we're adding now is, if you hold on a second, we've got little clouds floating through the sky, right? Is there anything more boring to track in a full model than particles? I don't think so. So what we decided to do was think about, I don't know if anybody's used Yamper at all, it's a Haskell engine, but it works on this idea of signals. So an automata, it's called automata, it's probably a bad name, somebody can write me a suggestion. Basically, you have this thing called an automata, which holds automatons, instances of automatons. Each one has a startup state, which never ever changes, so seed values, and then you give it a signal function, which is a function which, for any given time, produces a value of a, t, whatever you want to be. So we're using a signal, and conveniently, what I wanted to do was have something which moved across the screen, which is really just a linear line, a bit like a Bezier curve with only 2 points. So I thought, well, we'll just use a Bezier. I happen to have written a nice function that takes because a Bezier is also a time-based value. You give it a time from 0 to 1, and it goes from 0 to the end. I've written a thing that says toSignal, where you give it a duration and say, I don't want it to be 0 to 1, I want it to be from this for this length of time. And then you can just map over it, give it a sprite to render, move it to the right place, and play an animation. And away you go. Okay? All right.
Does play do?
Play. So it's actually an animation that's running. Yes, good question. I've actually got 3 different cloud graphics as different frames down in the animation, and all I'm saying is go to the appropriate frame and play that one. Every single frame. Okay? But yes, good observation. Okay, where am I up to? So I've done 6, 7. We've had a sneak preview of 7 because I was too keen. So I won't even bother with that one actually. God, I'm nearly there. This is good. The music is still playing. Right, so here we have our intrepid pirate captain. Here he is. So what I wanted to talk about here was how input is handled, essentially. Drawing the pirate is really quite straightforward. It's just this. It's basically checking the pirate's state and doing the appropriate thing, calling the right animation and rendering it onto the screen. The more interesting part, maybe, is the model and how the model is updated. So for any given frame tick, you can just pick about. It just says, oh, something's happened. Check things over. We have an input mapper. This is a very simple thing. It basically takes the gamepad input and the keyboard input and squidges them together, right? So again, it's just trying to work out what the current state of the thing is based on the inputs I've given it. and then based on the next state that I want to do, there's just a pattern match, and I have to produce this thing called an outcome. An outcome, it's a monad, but there's no real effect types in here. There's no error states. What would erroring mean anyway? You can't just crash out, right? You've got to say something to the user. Outcomes basically let you hold the state that you want to pass on to the next frame, and it gives you a convenient way to add additional events. In this case, a respawn event, or a sound, or the walking sound. So when he moves along, he goes doop, 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 doop. Right. And then the only other thing I was going to add to all of that, the final piece of the puzzle, is the bit where he flashes when he falls down from the top of the screen. So when he starts, he kind of goes, flickers on and off in traditional pixel art style. And again, that is accomplished with a signal again. One second. Yeah, here we are. This is a slightly more complicated composition of signals. We don't have any stateful signals, which is what you hear about a lot, mostly because I'm not clever enough to understand how they work. But these ones are signals of booleans. The first one simply says, should you be flashing now? When was your last respawn? Are you within 2 seconds of that? Yes, you are, and you're on. The second one says, is based on a pulse. So you don't get to choose when the pulse starts, but you can just say I need an interval of 100 milliseconds. You don't have to use booleans, it just happened to be 100 millisecond pulses like that, on, off, on, off, on, off. We then we do a combination. So again, that's like a product operation. It's just taking the two and squishing them together into a tuple. And then we have this thing called a signal function, which is just a function A to B, but it's actually a combinator because it's really taking a signal A, T to A, time to A, and producing a time to B, right? So it's a combinator. And then all we do is we pipe the combined signals into the combinator and say what time it is, and it gives you the answer. Okay? And you get a nice little procedural animation. It's very loosely based on a piece of work that came out of Microsoft Research in '96 called FRAN, which is functional reactive animation, where you're trying to say any animation should be describable by the current time. It's the same sort of idea. Okay? I think that's me. So I put the game back in. Woo! I'll get off there.